Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about what is a transaction and then the behavior of transactions. So let's take a scenario where we are writing to two files. So let's say this is a file F1 and we have another file, let's say F2. So what I'm going to do here is in F1, I'm going to write if any new employees come and join my company, then I'm going to write their name and then their salary and then their all the information in file 1. And whenever in file 1 I write a new employee, and then I'll count how many total number of employees are there, and then I'll keep that count in file F2. So let's say I have 3 employees in my system, so A, B and C, and therefore in A, B and C, and then their say salary is 100, 200, 300, and then the total number of employees are 3, so therefore the count here is 3. Alright, so let's say this is what I am doing, and then another employee comes, employee number D, and his salary is 400. So I'm going to update the count to 4. Right, so let's say this is how it is going on. So what happens is that, let's say there is another employee that came in and his name is E. Okay, so I already updated in the employee name in E in my file F1, and just after that my power shuts down. Okay, so my computer is gone, and what's going to happen is that I just wrote here in file F1 the fifth employee, but I didn't have a chance to update in file F2 the count to 5. So when the machine reboots, right, so when the machine reboots, then what's going to happen is that in file 1 I have 5 employees, in file 2 I have count as 4. So therefore this is not a consistent state. Okay, so what is a consistent state? So it's not a consistent state. What is a consistent state? So whenever I have whatever number of employees I have here, the count is matched to that number of employees. Alright, so this is actually the problem in the file system. However, in database system we need consistent state. So whenever if the power's gone, and then when the power comes up, I want to have my database in a consistent state, and transactions are the features that keeps database in a consistent state. Okay, so this is what is a transaction is a feature, and this feature is basically a shift change from your file based system to the database system, and database system implements transactions, and we will learn what is a transaction in the next slide. Let's take another scenario, another example. So in this example, let's assume that you have in your bank you have 2 accounts. One account is your checking account, so let's say this is called checking account, and then you have a saving account. So what you're doing is that, let's say in your checking account you have 5,000. You have $5,000 in your checking account, and then on your saving account, let's say you have $4,000. All right. So what I'm telling you, you are told. So you are told to transfer $1,000 from checking to your saving account. All right. So if you want to do, this is the work that you have to do, this is a task that you have to do. To do this task, what are the steps that is involved? And those steps are, number one, first thing is that you read how much in my checking account, in my C account. Okay, then the next step that probably you're going to do you are going to deduct 1000 from whatever you got in step 1. So whatever you read in step 1, so you deduct 1000 from that. Deduct 1000 from C account. Then the next step that we are going to do, write the deducted after you deducted whatever the amount, so write that new amount in checking account. Then step 4 is will be read saving account, deduct addition, add, so add $1000 to saving account, and then the last step would be write the new amount in the saving account. So these are the 6 steps that you are going to do in order to achieve this task of transferring $1000 from your checking account to your saving account. And essentially what is going to happen is that all these steps together, this is called a transaction. Okay, so transaction is basically steps to achieve a task. Okay, so transaction consists of multiple steps, or it can consist one step. That's not an issue. Okay, so multiple steps, so those steps together called a transaction. And let's do couple of observation. So what I have observed here is couple of things, like the first observation number 1. So what I say is that, let's say I deduct 5000, so this become, so let's see, like, what is the total amount at the start. The total amount before I do any of these steps is $9,000, right, together checking and saving. And then what I did, I deduct 1000 from here, so therefore the new amount here became 4000, and the new amount here become 5000. So what is the sum again? Is $9,000. Okay, so therefore the sum of checking and saving remains what was before. All right, and this is called consistency property. Okay, that means before the tasks, your database, your system is in one state, and after you have done the 6 steps, your database is on a similar consistent state. All right, so let's say another observation number 2. Let's say while you are doing these steps 1 2 3 4 5 6, let's say after step number 3, okay, so after step number 3 something happened. Okay, so after step number 3 something happened for which you are not able to do step 4 5 and 6, right? So that means, so this is consider the case that you have already updated, you have already taken 1000 from from this checking account, so therefore the checking account amount becomes 4000, and you have not yet updated anything in the saving account, you have not yet added in anything in the saving account, therefore your saving account amount is still there with 4000. Okay, what is the initial value, right? So in that case, what we should do, should we keep that one in this state? If we keep that one in the state, definitely we are not going to a consistent state. So in that case, what is going to happen is that we are going to, whatever steps that we have done 1 2 3, we are going to go on the reverse order. That means we want to undo all those things whatever we have done. You get my point? So that means either we do all the 6 steps or we will not do anything. Okay, that is called atomicity. Okay, so essentially the atomicity attribute or atomicity property makes sure that the transaction will be done in full or the transaction will never be done. That means if you start from step 1, you finish step 6, or if you cannot finish for whatever reason, then get it back, don't do anything. That means in this case I have done this 1 2 3 steps. What I'm going to do, I'm going to add 1000 because I have subtracted 1000, so then I'm going to reverse, I'm going to add 5000 and write that 5000 to back. Okay, and then that property is called atomicity, and then transaction has that property. Okay, number 3 property is like, say for example, you have done all these 6 or whatever the 6 steps that we have explained here. So you have done all these 6 steps. After you completed all the 6 steps, then you are telling back to the person who has given you this task. So you are saying that my task is complete. So when you say that your task is complete, then this is how it should be looking like. So when you say that my task is complete, so it was like, this started at 5000, and this is what initial amount is 5000 here, and initial amount is 4000 here. So when you complete these 6 steps, this will be 4000 here, and this will be 5000 here. So when you say that, when you go back and then tell that person who has given you the task that this task is complete, that means this value of 4000 5000 remains permanent. Okay, that means once you say this complete, that is the value, it's 4000 here 5000. That is called durability property. Okay, so that means after the step 6, the amount of checking, the amount of saving is permanent. All right, number 4. So number 4 observation is this: let's say when you are doing this task, that you are told to get $1000 from this thing. Let's say this is a task 1. Another person said to me that another task 2 is deduct now $100 from checking to saving. Okay, so this is a task 1 and this is a task 2, and this task 1 and task 2 can be given at the same time. That means this is a transaction and this is another transaction. This transaction are running now concurrently, and this is called concurrent transaction. But whenever these two transaction works in concurrent, we just want to make sure that they do not overlap the other guy's work. Say for example, if the task 1 is now on the step number 3, when the task number 1 is now in the step number 3, he has written the new amount here in the checking account, and let's say at that time, but remember this task 1 is not finished yet. Okay, then task 2 started. In a task 2, when it starts, so it is going to go on and read the amount in this checking account. But whatever amount he is going to read in the checking account, that should not be the amount what happened in the step 3. He should see the person who is doing the task 2, he should see what was the amount at the start of the game. So at the start of the first transaction, whatever the amount, that amount is going to say. He is not going to see any intermediary result. That means the transaction will happen in isolation. Okay, so these are the 4 fundamental properties of a transaction, which is called ACID properties: atomicity, consistency, isolation, and durability. And Oracle is implemented, or any database in fact is implemented to respect these ACID properties, or to basically they all implement. Whenever they say that we are going to have transaction, the transaction by default will observe all these 4 properties that we have explained you at this time. So so now you understand what is a transaction, and also you understand what is a concurrent transaction. Then how Oracle is going to manage these transactions? These transactions are managed by SQL statement called transaction control language. And what is a transaction control language? They are commit, rollback, set point. So let's say you start your transaction at this point. You don't have to give any begin trans or any trans. Anytime when you start as SQL statement, so that's how the beginning of your transaction until you do a commit or you do a rollback. Okay, so until you see this thing, that is the end of a logical transaction. Also, whenever you are writing a DDL like create table, okay, so that time also it is going to do it's going to end the transaction. All right, so now if this is a timeline, so basically this is a, like your task, that whatever I've given you in this thing, 6 steps, right? So this is a step 1, step 2, step 3, step 4, step 5, step 6, and then we give a commit to complete the transaction. If for whatever reason in step 3 we say that okay, we cannot do any more step 4, step 5, step 6, then we give here a statement called rollback. If you give a rollback, it's going to redo whatever things are done, step 1, step 2, step 3, it will nullify it, and then we'll go back whatever was the database state at the time of starting. Okay, so using this commit, rollback, and then save point is something like, you can in a rollback, you roll back to the last commit point, but by putting a save point we mark that this is the save point that we're going to roll back. So instead of rolling back completely, we can roll back partially by using save point statements. Okay, so this is all about transactions, and in the next set of videos we are going to in detail understand what is this atomicity properties and then how Oracle is going to implement those things.